All right, this is Mr. Burgess once again, and we're continuing our work with exponents. And today we're going to talk about the quotient of powers rule. And it's very much like the product of powers rule, but a very important difference as well. So whenever we have two numbers that have the same base, and an exponent on them, like I'm going to just throw one up there for example, like if I had 3 to the fourth divided by 3 to the second, for example. Well, that's what we're trying to describe here. Some number to a power divided by another, that same number to a different power. And all we have to do in this case is subtract the smaller exponent from the bigger one, or in this case, 4 minus 2. So if you did that, then you just end up with 3 to the second power. And there's some iterations to this, so we want to be careful as we go through this to describe all the different possibilities, because there's more to it than just what we saw in this little example. So let's go to the next page. For example, if I have x to the fifth over x to the second, another way to look at this is just write out 5 x's on top, 2 x's on the bottom, and then cancel out anything that matches on top and the bottom. So 1x off the top, 1 off the bottom, another one off the top, another one on the bottom. And that leaves us 3 x's on the top still. So we could put those back together in exponential form, and that just gives us x to the third power. And if you think about it, since these x over x, when we cancel them out, equal 1, all we really have left on the bottom is 1, and we don't even have to write that. However, let's look at this next one. This time we actually have more x's on the bottom. So when we cancel out 1x off the top, 1 off the bottom, another one off the top, another one off the bottom, then remember, each time we have the same thing on the top and the bottom, that equals 1. So we have 1 times 1. So that's going to leave us 1 on the top. And then I kind of got that little circle going a little crooked there. But so what that's going to leave us is 1 on the top and 3 x's on the bottom. So x to the third on the bottom. So what we did in order to keep our exponent positive, we subtracted the smaller one from the bigger one. And so we ended up with 1 over x to the third. Well, this brings up a question, some different questions that could happen as well. Okay, so we want to keep our exponents positive. So again, if we write out the rule, this is going to be 5 to the 7 minus 4 power. So we're taking the smaller one from the bigger one. And so that's going to end up being 5 to the third power. So we're subtracting exponents instead of adding them like we did on the last lesson. Okay, here we got 8 to the fifth over, don't forget there's a 1 on this one. So this is going to be 8 to the fifth minus 1, which ends up being 8 to the fourth power. All right, down on this next one, 6 to the seventh over 6 to the second. That would just be 6 to the 7 minus 2 power, which simplifies to be 6 to the fifth power. Okay, let's keep it going. There's a few more problems that may not be on your notes, but let's go ahead and do them. So x to the sixth over x to the fourth, that's going to equal x to the 6 minus 2 power. And we're going to kind of speed this up here in a minute. Or x minus 4 power, excuse me. 6 minus 4 is 2. So this would be x to the second power. Looking at this one, what's 7 minus 2? 5. So this is going to be b to the fifth power. Okay, what's 7 minus 6? That's going to be 1. So it's going to be h to the first power, or just h, right? All right, on this one, we're trying to keep it a single positive exponent. So if we subtract 9 from 3, like we've done on all of these other ones, we're going to end up with a negative exponent. So we're actually going to take the smaller exponent down to the bottom and subtract it from the 9, which is going to leave us 1 left over on the top because those all canceled out with 3 on the bottom. And we're going to end up with a to the 6th power. So remember from our previous page where we had 3 a's on the top and 9 a's on the bottom or something like that. And we canceled the 1 off the top and 1 off the bottom. We just kept doing that until everything was canceled that could be canceled. And that left us, if everything disappears on the top or the bottom, what's left behind in its wake is just 1. And then whatever's left in the other position. All right, so what if we have more than one variable? What if we have b's and a's? Well, you just do the same thing. You just do them separately. So if you got the b's, so in this case, we're going to subtract the 2 from the 6, and that will leave us on the bottom b to the 4th. Now, before we put any 1s or any other numbers, let's look at the other one. A to the 5th over a to the 2nd. So that means we're going to take the 2 up and subtract it from the 5. Minus 2 there. So 5 minus 2 is 3. So that will leave us a to the 3rd on the top and b to the 4th on the bottom. All right, let's try another one. Then maybe we can do it in a little different light here. So let's take a look at the a's. Who has the most a's, the top or the bottom? Well, the top has 5, the bottom has 4. So if we subtract 5 from 4, we're left with 1 on the top because there's 1 more on top than there is on the bottom. Well, who has the most b's, the top or the bottom? Well, the top does, but how many more does it have? It has 1 more than 2, so we end up with b to the 1st power, which could just be simplified to be ab. All right, let's look at these x's. Who has the most x's, the top or the bottom? Well, the bottom does. It has 3 more, so in our answer, we're going to have an x to the 3rd on the bottom. For our y's, we have y to the 1 on the bottom, y to the 2 on the top. So on top, when we finish, we're going to have y to the 1st power. And then for z, z to the 7th over z to the 3rd. So there's 4 more on top than there is on the bottom, so that gives us z to the 4th. So there is our simplified expression using this rule of the product or the quotient of exponents. A couple more. Y to the 6th over y to the 4th. So the top has 2 more than the bottom, so 6 minus 4 is 2. And then 3 minus 2 is 1. And all we'll have left on the bottom is a 1, which we don't need to show. On this one, we have 5 more on the bottom than we do on the top, because 6 minus 1 is 5. So y to the 5th on the bottom. And we have 1 more z on the top than we do on the bottom, so that's going to be z to the 1st on the top over y to the 5th. So there's our expression. All right, let's keep going. How many more have we got? We got a few more. So just to give you an idea, let's hang in there and do a couple more, okay? All right, so the x's, we've got 2 more on the bottom, so x to the 2nd on the bottom. Oh, I missed that extra x. We got an extra 1 there. So that means we actually had 6 on the bottom. So we have 3 more on the bottom than we do on the top. So I've got to add 1 on there. X to the 3rd left on the bottom. Oh, would you look at this? The x z to the 6th and z to the 6th cancel each other out. So all together, we're going to be left with 1 on the top and x to the 3rd on the bottom. So let's watch it carefully on this one as well. So right off the bat, we can see that the c's are equal, so they would cancel each other out. And then on the b's, we have 5 more on the top than we do the bottom, so b to the 5th on the top. And on the a's, we have 4 more a's in our exponents on the bottom than we do the top, so a to the 4th on the bottom. And since the c's canceled out, that would just leave us with 1, and we don't need to put it in there because 1 times anything is itself. Wow, these are looking a lot easier than I thought. Okay, now what can we do to change things up? Well, we could throw a regular fraction in there with the other one. So what's 24 over 4 equals? Well, that's just, if you simplify, that's just 6, right? Well, what about z to the second over z to the fifth? Well, there's 3 more z's in our exponent on the bottom than there is on the top, so we're going to be left with z to the third on the bottom. All right, what about 5 over 10? When you simplify that, that comes out to be 1/2, right? And then our y's, they cancel each other out, so let's make a note of that. Cancel each other out. Oh, wait, I missed something. You got to be careful here. I almost missed something. On the y, there's actually a 5 on the top there, isn't there? And 1 on the bottom, so there's actually 4 more y exponents on the top than there is on the bottom. And then on the z's, there's z to the fourth on the top, z to the second on the bottom. So there's 2 more z's on the top than there is on the bottom. And there's our simplified version. 1 y to the fourth, z to the second over 2. Okay, we're about there. 49 over 7. If you simplify that fraction, that just turned out to be 7 over 1, or 7. And then for our v's, we have 3 more on top, so 5 minus 2 is 3. So 7v to the third over 1, or just 7v over to the third. 45 over 72. I happen to notice that 9 will go into there. So if I divide each of these by 9, divide by 9, 45 divided by 9 is 5. 72 divided by 9 is 8. And then 6 minus 4 is 2. We're going to be left with w to the second on top. All right, on this one, we've got 5 over 35. 5 will go into each of those. 5 will go into itself 1 time and 35 7 times, so that leaves us with 1/7. There's 5 u's on top, 1 on the bottom, so u to the fourth on top. And then v to the third over v to the fourth, so that means that we have v to the first, or just v on the bottom. So let's write that one more time. 1u to the fourth over 7v to the first. And there we have it. Okay, so today's assignment is number 56, exponent quotient properties. So give it a try. I think you'll like it, and it's just one more tool in our arsenal to solve exponents.